Welcome to the International Code Council's overview of changes to the 2012 International Plumbing, Mechanical, and Fuel Gas Codes. My name is Lee Clifton, Director of Plumbing Programs, and here also with me is Bob Gunther, Director of Mechanical Programs. The opinions expressed in this presentation are those of Bob Gunther and myself, and do not necessarily represent the official position of the ICC. This program is designed to provide a general overview of the notable changes that occurred between the 2009 and 2012 editions of the International Plumbing, Mechanical, and Fuel Gas Codes. It is intended to acquaint users of the PMG codes with some of those provisions that have been added, modified, or clarified with the previous edition. Only a limited number of changes will be addressed today. Our new publication on the significant changes to the 2012 International Plumbing, Mechanical, and Fuel Gas Codes are available right now. The purpose of this publication is to familiarize plumbing and mechanical officials, building officials, fire officials, plans examiners, inspectors, design professionals, contractors, and others in the construction industry with many of the important changes that have taken place in the 2012 IPC, IMC, and IFGC. Throughout this book, each change is accompanied by a photograph, an application example, or an illustration to assist and enhance the reader's understanding of the specific change. A summary and discussion of the significance of the changes are also provided. Each code change is identified by the type, be it an addition, modification, clarification, or deletion. Internationally, code officials recognize the need for a modern, up-to-date plumbing code addressing the design and the installation of plumbing systems through requirements emphasizing performance. The International Plumbing Code in the 2012 edition is designed to meet these needs through model code regulations that safeguard the public health and safety in all communities, large and small. Let's take a look at just a few of the changes that have taken place. In Chapter 2, the definitions of grease interceptor has been modified for consistency with current industry terms for the two general types of grease interceptors being used in plumbing installations. The provisions of Section 1003.3.4 addressing grease interceptors and automatic grease removal devices were never intended to apply to gravity grease interceptors. The new terminology now makes a clear distinction between the two types of grease interceptors, hydromechanical and gravity. The revision to the definition, along with the changes made in Section 1003.3.4, placed the IPC in better alignment with product standards and industry terminology. Both types of grease interceptors require diligent effort by restaurant facility managers and staff to ensure that they are regularly maintained and properly serviced. For a grease collection device to work correctly, it must be properly designed, installed, maintained, and serviced regularly. The identification requirements for plumbing products and materials have been clarified. The modification to the identification and provisions of Section 303.1 clarifies the intent of the code that products and materials shall bear the identification of the manufacturer as well as identification requirements that are referenced by the applicable standard. As a result of the modifications made to Section 303.4, all plumbing products and materials must now be listed by a third-party certification agency. Table 303.4 was deleted as a result of the modifications made to Section 303.4. The following changes in Section 802.2 are considered logical and provide consistency with other allowances in the code. The thresholds at which indirect waste piping is required to be trapped have been increased, and an exception has been added to address clear water waste. The graphic you're viewing illustrates that the new exception is fundamental and that traps are unnecessary for clear water waste in an indirect piping system. In the past, indirect waste piping was required to be trapped where it exceeded 24 inches in horizontal developed length, or 48 inches in total developed length. The justification for increased developed lengths without a trap, 30 inches for a horizontal measurement, and 54 inches in total developed length, is based on Section 1002.1, addressing fixture traps, including the allowance of 30 inches center to center for a combination fixture as permitted in exception number 2. A 54-inch total developed length allowance is simply the 30-inch horizontal length allowance plus the 24-inch vertical distance allowed from a fixture to its trap. The changes are considered logical and provide consistency with other allowances in this code. The single stack vent system method, similar to the Philadelphia stack drainage system, has been added as an acceptable venting system in the IPC. In a single stack vent system, the drainage stack serves as both a single stack drainage and vent system. The drainage stack shall be sized in accordance with Table 917.2. The stacks shall be uniformly sized based on the total connected drainage fixture unit load. The stack vent shall be the same size as the drainage stack. A 3-inch stack shall serve no more than 2 water closets. Now let's take a look at our drawing. The drainage stack and branch piping are considered as vents for the drainage system as a whole. Pipe sizing in a single stack drainage system is larger than in a conventional one. However, a significant cost saving is achieved by the reduction in the vent piping needed. This venting system serves as a viable alternative to the more traditional systems that are being used. The length of trap arms is limited, and the vertical drop from the fixtures is also oversized. Fixture connections that do not meet the requirements for a single stack system must be conventionally vented. Oversized unvented S-traps are the major components of the one-pipe system, instead of the conventionally sized and vented P-traps and fixtures that allow water to run off after the tap is closed to fill the traps with water to maintain the trap seal. The length of the trap arm is limited to reduce any suction buildup, and the stack is oversized to limit the internal air pressure and vacuum buildup. Stacks greater than 2 branch intervals in height are prohibited from receiving the discharge from horizontal branches on the lower 2 floors. The separate stack serving the lower 2 floors is required to connect to the building drain at a distance of not less than 10 pipe diameters downstream from the base of the connection of the single stack vented system. This proven method has been laboratory tested to determine sizing and installation requirements that provide proper venting to the drainage system. Bob Gunther will now take you through some of the significant changes that occurred in the 2012 International Mechanical Code.
This section in the 2012 IMC will require mechanical systems to be maintained in accordance with ASHRAE ANSI Standard 180. This will require a maintenance inspection for duct systems, air handlers, chillers, water towers, and numerous other components of an HVAC system. The standard also specifies at what intervals these components are to be inspected. Air dispersion systems have not been recognized in previous codes. They are now acceptable provided they are listed to UL 2518. Reference to that standard has been added to Chapter 15. The next part of this presentation will cover some of the significant changes that occurred in the 2012 International Fuel Gas Code. A change to Section 404.2 now states that CSST gas piping systems are to be installed in accordance with the terms of their approval, the conditions of listing, the manufacturer's installation instructions, and the provisions of this code. To contact the PMG Resource Center, please write down the following information.